Hello everyone, myself Srivalli, working as an assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. So today in this session, I am going to discuss about discrete mathematics subject. So before going to discuss about discrete mathematics, so let us see the overview of the presentation. So the overview of presentation, it includes statements and notations, connectors and truth tables. So next we have conditional statement, or we can also call this conditional statement as implication. So basically what is meant by this implication, or we can also call this implication as conditional statement. So here let us suppose here if P and Q are propositions, then P implies Q is a conditional statement or implication, which is read as if P then Q. So it has its truth table, and we can also write this as P implies Q. So here let us suppose we have two statements P and Q, and the P implies Q will read it as, right, P implies Q, and we will read it this as implies. And theoretically we will write this as if P then Q. Here we will write if P then Q. So let us see the word example here. So here if you observe, you work hard. P is a statement, it is work hard. And Q is a statement, you will pass the exam. So here if you observe, how to combine these two statements here by using the conditional. So here P implies Q. If you work hard, then you will pass the exam. So here we are just writing if P then Q, means we are including if then words for both P and Q statements. So if you work hard, then you will pass the exam. So if you attend the exams, then you will clear the backlogs. So like this we can write some examples by using this if P and then Q. Now what is the truth table for the conditional statement? So here also again we have P statement and Q statement, and we have the four possible combinations like true, 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 false, false, true and false, false. Now what is P implies Q? So the rule for this P implies Q is if the first statement is true and the second statement is false, the resultant truth value will become false. Otherwise it will become true. So if you observe here, if you observe, we have four possible combinations. Out of these four possible combinations, the second row is having first statement as true and the second statement as false. And in this particular situation, the resultant truth value will become false. Otherwise, it is true. This is a condition to get the resultant truth value of the conditional statement. So next we have biconditional statement. So what is meant by biconditional? So we can also call this biconditional statement as by implication. So here if P and Q are two propositions, then P by implies Q is a biconditional statement or by implication statement, which is read as P if and only if Q, or P if and only if Q will write, or we can also write it as P if Q. So this is also nothing but if and only if Q. So here if P and Q are two propositions here, symbolically we will represent this by implication statement with one line, both side arrows. Whereas implication is one line, one side arrow, and by implication is one line, both side arrows. This is a symbolical representation of both implication and by implication. So here if you observe the example, so P is a statement here, I am breathing, and Q is a statement, I am alive. So here P by implies Q, how you will write is I am breathing if and only if I am alive. So here this if and only if, it signifies the conditional statement here, that is biconditional or by implication statement. So here we have seen some examples of this biconditional also. Next, let us go for the truth table of the biconditional statement. So here if you observe, P is a statement, Q is another statement, and let us observe here we have the 4 possible combinations, and at last we have the resultant truth value. And what is the condition for this resultant truth value is, so here if we observe, if both the statements are same, the resultant truth value is becoming true. So here if you observe, P and Q statements are same. Whether it is true or false here, it doesn't matter here. But as both the statements are having the same statement value, true, that is, resultant truth value is becoming true. So in the last row, if we observe, we have both the statements. So here, as both the statements are same, the resultant truth value is becoming here true. Otherwise, in the rest of the rows, as we don't have the same statements, then it is becoming the resultant truth value as false statement. So this is the truth table for the biconditional statement. Now let us discuss tautology. So basically what is meant by this tautology? So as we have already seen all the 5 connectors, from these 5 connectors only we are going to discuss about tautology, contradiction and contingency. So here if we observe tautology, the definition of the tautology is, a tautology is a formula which is always true for every value of its propositional variables. So or we also have another definition, a formula is said to be tautology if every truth assignment to its component statement results in the formula being a true. So that is nothing but if all the resultant truth values are becoming truths, then we can say that this is called a tautology. So let us see one example of tautology. So here I am considering one P and here I am considering one negation P. And here let us apply disjunction for both P or negation P. That is nothing but here P, negation P and P or negation P. So as we have only one statement here, so we'll be getting possible combinations are only 2 that are true and false. And if we have a P statement as true, negation P will become false. And as we have F statement here, the negation P will become true. So here applying disjunction for both P and negation P. So what is meant by disjunction? Even if one statement is true, the resultant truth value will become true. So here if we observe, out of these 2 statements, here P statement is true, that's why P or negation P will become true. And out of these 2 statements, here negation P is becoming true, then the resultant truth value will become true. And if we observe here, in this truth table, the resultant truth value all are truths only. As we got all true values, then we can say this is called a tautology. A statement formula is said to be tautology if all the resultant truth values are true. And next we have contradiction. So what is meant by this contradiction? So here a formula is said to be contradiction if every truth assignment to its component statements results in the formula being a false. Means if all the resultant truth values are false statements, then the resultant truth value will become false statements and we can say that is called contradiction. So let us see again one example here. P statement, and this is a negation P statement, and here we have P and negation P. So here if you observe again one statement and then we'll get 2 combinations, and negation P will become false statement and this will become true statement. And here we are going to apply conjunction. The conjunction rule is, even if one statement is false, the resultant truth value will become false. So here if you observe here, as we have the false statement, the resultant truth value will become false. And here if you observe, the P statement is false, the resultant truth value will become false. And the resultant truth value all are only false statements. That's why this is called a contradiction. So here on the whole, we can say that a statement formula is said to be contradiction if all the resultant truth values are false statements. So next consider contingency. What is meant by contingency? So here contingencies have both truths and false in their truth tables. So here we observe that we have true statements and also false statements here. So that is nothing but here. So in the previous tautology and contradiction, as we are getting all the false statements and we are saying that it is a contradiction, but combination of both truths and false statements, we are saying that this is called a contingency. So a sentence is called a contingency if its truth table contains at least one T and at least one F. So here a compound proposition is called contingency if and only if it is neither a tautology nor a contradiction. So it contains both truths and false in the last column of the truth table. So here let us consider one example. So that we can understand what is meant definition of the contingency here. Let us suppose here I am considering one P statement and I am considering one Q statement. So let us apply conjunction, or we can also apply disjunction for the statement. So here as we got two statements, the possible combinations are what? True, 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 false, false, true, and false, false. These are the four possible combinations as we have two statements. Now, let us apply the disjunction for these two statements. So, what is the rule of the disjunction? Even if one statement is true, the resultant truth value will become true. So, here if we observe in the first row, both are true statements, the resultant truth value will become true. And in the second row, we have one true statement, the resultant truth value will become true. And in the third row, Q statement is true, the resulting truth value will become true. And in the last row, if you observe, both are false statement. So, we'll not get true statement, and here we'll get the false statement. Now, if we observe in this last column here, it is combination of both truths and false. So, here we have true statements and here we have false statements. So, we can consider this is an example of contingency. The contingency is, it is a combination of both true statements and false statements. Suppose if we are getting here, suppose if you get here last column also true, then it will become, it is a tautology. Suppose if you are getting all false statements in the last column, then we can say this is called contradiction. So, these are all three derived from the connectives only, from the construction of truth tables of the connectives only, that is tautology, contradiction and contingency. Next here, let us see some examples by using all these five connectives. So, here let us suppose here I am going to consider implies, negation. This is one example I am going to consider, and construction of the truth table for this is, so here we have two statements, that's why we will get PQ, and also here we have another variable negation P, and here P and Q. So here if you observe here, P is true, Q is true, this is true false, and here we'll get false true, and here we'll get false false. As we have only two statements here, we'll get four possible combinations. So here negation P is, so what is meant by negation P is applying negation for the P statement. So here it will become false, and here it will become false, and here as we have false statement it will become true, and here we have false statement it will become true. And here P and Q, what is meant by AND? AND is nothing but conjunction. So here conjunction rule is, even if one statement is false, the resultant truth value will become false. So here in the second row, third row and fourth row, if we observe here, we are getting all false statements only, as we have false statement in this P or Q statement. And in the first row, as we have two true statements, the resultant truth value will become true here. So now next we have, on the whole, this is a result here. So just apply here, just represent this as a result and write down the truth table for this. So applying the implication for both P and Q and negation P. So what is this applying the negation for P and Q and implication? So here if you observe, in between the two statements, we have implication. What is implication? Implication is also called as conditional statement. What is meant by conditional statement? Even if here, if you observe the condition of the truth table of the implication, so out of the two statements, if one statement is true, first statement is true, and the resultant truth value become false. So here if you observe here, as I have represented the total question as result, output, So I'm just representing here R. And in this R, here I'm applying implication for both negation P and Q. So here if you observe, first statement is false and the second statement is true, then the resultant truth value will become false or true statement here. It will become true statement. Why? Because what is the condition of the implication here? If first statement is true and the resultant truth value will become false statement here. And in the second row here, false and false we have, then it will become true. And here if you observe, the first statement is true and the second statement is false, the resultant truth value will become false. And in the last row also, first statement is true and the second statement is false, the resultant truth value is becoming here false statement. So here, this is the total resultant of the question P and Q implies negation P. So what we have discussed in this session is, today we have discussed about all the statements, notations and construction of the truth tables for the all connectives, and also we have discussed contingency, contradiction and tautology. In the next session, we will be discussing other connectives, and along with the other connectives, well-formed formula, what is syntax, semantics, validity and satisfiability. And along with this, we also discuss converse, inverse and contrapositive. So by this, we'll end the session. Thank you.